Okay, I'll go back. I'll repeat what I say. So this is the last section, section 10.3, comparing two variances. We're going to be using the F distribution, the same distribution that we used in section 10.4. This distribution is positively skewed. It starts at 0 and it has 2 degrees of freedom of numerator and degrees of freedom of denominator. And the curve shape will change according to the degrees of freedom. So this is the F distribution, and we will be using that to compare two population variances. You want to purchase, this is an example, guys. You want to purchase stock in a company and are deciding between two different stocks. Okay? Because a stock's risk can be associated with the standard deviation of its daily closing prices, you randomly select samples of the daily closing prices of each stock to obtain the results shown at the left. At alpha equals 5%, can you conclude that one of the two stocks is a riskier investment? Assume that the stock closing prices are normally distributed. All right. He says, can you check if one stock is a riskier investment? He didn't say which one is riskier. He said, if one is riskier than the other, but we don't know which one is riskier than the other. And the risk according to the standard deviation, whether the standard deviation changes too much. So this is a test of standard deviations. And here is how you state, the null and the alternative hypothesis when you compare two variances. So I'm going to show you the two scenarios. Actually, there are only two scenarios here. Here's the first scenario. Sigma 1 square is called the variance, the population variances, guys. And sigma 2 square is called the population variances of population 2. So you're comparing two. Either this, not equal, or that. Either a two-tail test or a right-tail test. And we're not going to do a left-tail test because this distribution is positively skewed, toward the right. And even when we do a two-tail test, we're going to take the part, that goes to the right only because this distribution is skewed to the right. So if any questions I ask you here, I won't be asking you to do a left-tail test. It will either be a two-tail test or a right-tail test. This is a right-tail test because it says greater than, and this is a two-tail test because it says different from. And usually, guys, the sample that has a larger standard deviation is labeled as 1, and the sample that has a smaller standard deviation is labeled as 2. So as you can see, this is a stock B right here. It has an S2 equal 5.7, and that's why the author labels that as 1. And stock A, it was labeled as 2 because it has a smaller standard deviation. So this is how the labeling is going to work always. So HO will be, since he didn't say which one is riskier, he said one is riskier than the other, so it's either equal or not equal. So HO will be sigma 1 squared equals sigma 2 squared, and HA will be sigma 1 squared not equal to sigma 2 squared. And this is where the claim is because he says riskier. That means they're not the same. In order to do this, we're just going to use the calculator, guys. I'm not going to do any work by hand. So let me show you how to use the calculator for this one. Clear? Go to stat. There's one test, guys, that we haven't used yet right here. Can you tell me which one? Not an interval. We're not doing two proportion interval.
Two sample F test.
Yes, the two sample F test. That's it. That's the last one. enter stats. By default, should be at stats. Okay, look, guys. You were given S1, N1, and you were given S2, N2, and the calculator is prompting you to enter S1, N1, S2, N2. So S1 is 5.7. N1 is 31. Okay. Because you have 2 degrees of freedom, just to tell you what you saw when I show you a visual of the F distribution, the degrees of freedom of numerator will be 31 minus 1. So N1 is always the numerator and N2 is the denominator. So 31 minus 1 will be 30, and 30 minus 1 for the second one will be 29. But you don't need to input this into the calculator. 3.5. N2 is 30. And we're testing different from. Calculate. There you go, guys. The test statistic is 2.65 and the p-value is 0.010. What is he asking us to test at what level? So F is 2.65. There you can see the output of my calculator, guys. And then F is 2.65. Which is less than 5%. So you reject the null hypothesis and you conclude that there is enough evidence. There is enough evidence to support the claim that one stock is riskier than the other. All right. And let's do this one right here, exercise 7. To give you a better feel about how to do this test. Then you should be able to go back and do the homework. A medical researcher wishes to see whether the variance of the heart rates in beats per minute of smokers is different from the variance of heart rate of people who don't smoke. 2 samples are selected and the data are shown. Using alpha equals 5%, test that there is enough evidence to support the claim. Okay, so let me just go and write down the claim. Okay, he wants us to check if the variance of smokers, of heart rate of smokers is different from variance of heart rates of people who don't smoke. So it's clearly different, not equal to, guys. You can do sigma 1 equals sigma 2, or you can do sigma 1 square. It's the same thing. But since we're doing variance, let's square it. But even if you don't square it, it's not wrong. Okay. You notice, guys, S1 square is bigger than S2 square, and he already did the bigger value in S1, so we're good here. And we're going to use a 2-sample F test. All right. Let me bring the calculator up and do this together. All right, so clear, stat, tests, scroll up, 2-sample F test. Okay. N1, S1 is 36. Oh, S1 squared. Okay, any idea, guys? He's asking for S1 here, not S1 squared. This is S1 squared. What do I do here? You don't enter 36. It's wrong. He wants S1.
Take the square root.
Take the square root of 36. Okay, here's how you enter the square root of 36. Second, you can do it by hand first using the calculator and then put it later. It doesn't matter. Then 26. Okay, S2. I have S2 square, guys. That's not what I want for the calculator. I need S2, so you take square root of 10. And then N2 is 18. And then we're doing different from and calculate. So F is 3.6 and p-value 0.0084. Which is less than alpha, of course. So we reject HO. And this is the claim. Then we support the claim. There is enough evidence to support the claim. For the last two steps, guys, I'm not bringing anything new. It's the same conclusion as you learned in chapter 7. There is enough evidence at the 0.05 level of significance. So that should be a good review of chapter 7 and 8 and how to state the conclusion to support the claim. Okay. And let's see. We got we have one more, we'll do it, and then that should be it. All right. You will get the handout with complete notes. Last one, guys. It should take me another 5 minutes and we should be done with it. The standard deviation of the average waiting time to see a doctor for non-life-threatening problems in the emergency room at an urban hospital is 32 minutes. A second hospital, the standard deviation is 28. So S1 is 32. And S2, guys, is 28. If a sample of 20 patients was used in the first case, so N1 is 20, and 18 in the second case, is there enough evidence to conclude that the standard deviation of the waiting time in the first hospital is greater than the standard deviation of waiting time in the second hospital? So guys, it's a right tail test, greater than. And this is the claim. Okay, let's run the test. Two sample F test. I'll bring the calculator up. All right, so we go to stat, tests. S1. S1 is 32. N1 is 20. S2 is 28. N2 is 18. And we're testing that sigma 1 is bigger than sigma 2. Don't forget to change that. Want to do a draw? Let's do a draw here. You see, it's a right scoot test. F is 1.31. Let me see what the p-value. I didn't notice the p-value. And the p-value is 0.2922, so it's big. 0.2922. And let's draw the conclusion. Which is, you guys agree with me, it's bigger than alpha. So we fail to reject the null hypothesis. And there is not enough evidence to support the claim. Enough evidence at the 0.05 level of significance to support the claim. For F, guys, actually it was easy even to compute this by hand if you want. As I told you, the formula, as you notice when I introduced the F distribution, it's S1 squared over S2 squared. So if you try to compute it, take S1, which is 32, and square it. And take S2, which is 28, and square it. And let's see if we get the same answer. I'm going to just show you that it should be the same answer. I mean, you don't have to do that, but just to show you. So I'm going to second and quit. And I'm going to do 32 squared divided by, what was it? 18 squared. Oh, 28 squared. My mistake. 1024. Here you go, guys. 1.31. 1.31 if you round it. All right.